Active Directory service, perhaps the system that feeds the data into the data warehouse in the first place, the order processing system. So what are you going to get when you pick up that meatball? This is how the blueprinting type approach can really pay off. So what's some of the output you get from this in the real world? Well, what we've done is take the output of that data and put it in a really simple to easy to consume approach, which is based in Excel. So thanks Microsoft for that, because everyone knows how to use Excel. And the good thing about this is that every time somebody goes up to the top of Excel and clicks data refresh, this data is always up to date. So imagine coming in 9 o'clock in the morning, you hit refresh, and you know immediately what's in every data center, in every location, every application, every server that's installed. But then the solution takes it to the next level and actually refers to the groups of systems in language that you understand. So you don't really want to know that you've got Oracle 9i running somewhere. You actually want to know that it's the cache register access gateway system. And that system happens to talk to the Active Directory service. And why is it talking to the Active Directory service? Because it's doing a DNS lookup. And why is it, and what are the servers involved in that? Well, we've got the Argentina electronic funds transfer server talking to data domain controller number 1. So imagine if you had this data in your environment, would that be of any use to you? And how does that have knock-on implications for security? Well, let's see what else we can get from this. This is one of the slicing screens where you can say, actually, I want to run some scenarios before I migrate these services into the cloud. So you could say, for example, I want to see, let's say, all of the Dell servers which are running 32-bit Windows because I'm going to do a tech refresh and turn all those servers off or upgrade them to HP or perhaps move them to a public cloud. In that scenario, you can just select the data that you want to see, and on the right-hand side, it'll come back and tell you your line of business systems. So that's quite a powerful data set to have. If we then go on and say, well, now I've decided what do I want to move into the cloud, then how can I check that I'm secure and ready to do that? Well, the first thing you can have a look at, if we take the example of PCI compliance, is imagine in your organization you handle credit card data. Credit card data comes under the controls of PCI compliance, and typically organizations segregate their networks into different zones. So there could be an internal PCI compliant zone, an internal non-PCI compliant zone. And by having that data in the system as well, you can automatically say, right, there's this communication going from the non-PCI zone to the PCI zone. And I can see, for example, that the reason that's happening is because of the Oracle server lookups between these servers. Now, it might be at the top there that the system has detected some external PCI systems talking to internal non-PCI systems, and that might actually be a complete contradiction of the security constraints. So if you've already got environments that are not compliant, then the last thing you want to do is take those up and put them in your brand new shiny private cloud or public cloud, because you're already inheriting a whole new set of security challenges. So at least start off by having this overview at a very high level of what you've got and how bad the situation is, or how good the situation is. So what do we find when people try to do this in practice? Well, I can tell you that I was quite surprised when we started to realize this, but most clients, when they try to move into cloud technology, from a security point of view, they say, oh my God, how am I going to set up my firewall? You know, I've had firewalls throughout the organization. We've been building up firewall rules over the last 5 or 10 years. It's a complete mess. And there's no document I can go to that says, you know, here are the 10 different ports I need to be opened for my SAP system to work, for example. So with this scenario, we just have the workbook automatically calculate it for you. So the data warehouse reporting system already has 17 connections within the same security zone. But in this case, I know that if I move it to have this type of communication working, I'm going to have to open ports 53, 123, and 1521. And why do I want to open those? Well, it's because there's a DNS lookups going on those ports. So if anyone comes to you and says, what's the real justification for moving this process first, and what are the security implications, you've got real data to base it on. And in fact, because it's up to date on a daily basis, right before you do your migration, you can press refresh and see if anything has changed, and therefore call off the migration at the last minute if you have to. What else can you look at in this area? Well, what I'd say is you're going to need security processes that are optimized for this new way of working. Don't think that you can take the existing approach to managing servers or networks and expect that to work in the cloud computing scenarios. So go out and find a tool. Arch is an example up here, but there are various different tools you can use which have those security workflows already built in. And use those to deal with new challenges, such as the one of self-service provisioning. I mean, what are the security implications of having your users go ahead and create a brand new environment on the fly and copy your business data into that environment? Also, have a look at technologies for what I'm calling hyper consolidation. If you're going to move into the cloud, the first thing you need to do is to reduce the size of the problem as much as possible. I was at a meeting at an airline at the end of last year, and the guys at the airline were talking about their data center, and they're explaining one of the big rooms they've got in the data center with about 1,000 servers in there. And they're saying, on this side, we've got all these racks of servers. They're mainly HP DL 360s and 580s, that kind of thing. Over here, we've got core network switches, then some distribution switches, then some edge switches. Over here, we've got all of our storage frames. And they were talking to a guy who I had with me in the meeting from another company, and they said to him, look, we want to shrink down our environment. What can we do? So the guy did a bit of calculating, thought about it, and he said, well, you're going to need another rack. And they said, well, of course we're going to need another rack. We know we're going to have to buy some kit. The question is, how many racks are we going to need? And the guy said, no, you don't understand. I can take all of your servers, all of your networks, all of the cabling, all of the fibers, all of the storage, and replace all of these 350 servers with one rack. Now, when I heard that, I was quite surprised, because imagine the scenario. You've got a massive room, and in the center of it, they're going to end up with one rack sat in the middle. So to them, that was an eye-opener, and I'm putting this up as a pointer so you can go and investigate those kind of technologies, because if you go for the hyper-consolidation route first, then you can take that you've built and move that into your private or public cloud, or better still, the hybrid cloud. So that's analysis of myth number one, and I'd say on this basis, that myth is busted. You can do this. Myth two. I can't comply with data security standards using cloud technology. Well, having done the research, this is based on data again from McKinsey, there are actually some inhibitors and blockers that people are legitimately concerned about. And of course, they come into the areas you can see here around recoverability, confidentiality. But the good news is there's plenty of guidance of what you can do to investigate this. So I'll leave these details on the slides. You'll be able to get these from the website afterwards and refer to them. There are some regulations. 27002 is an advisory that gives you the advice on how you can set up your systems, and 27001 is the actual certification that you can go for. If we take one of these examples right now, then the PCI area in the latest version has been updated. So previously people were concerned about having PCI systems on the same VM environment as non-PCI systems. They thought it doesn't have to be an air gap, don't have to have a complete different set of hardware. Now they've updated this to take that into account. But what if you're considering using a public cloud or having a service provider run your private cloud for you? Well, it turns out that the service provider can either have their own assessment or they can do it as part of your assessment. Now the problem with that is if you're paying for a PCI assessment, you're suddenly paying for an assessment in someone else's area, someone else's cloud, someone else's data center, and your prices for that, your cost for that assessment is going to go up. So what else can we do about that? So I'll explore that point a bit later on, in fact, in the next myth. So for myth 2, I'd say, actually, that's probably plausible. You do have to think about which security constraints are going to apply to your hybrid or public cloud solution. So myth number 3, data in the cloud can't be trusted. How can I keep my data confidential? Well, I could talk all day about the different things you can do to keep data confidential, and so I guess you guys will already be familiar with the typical methods of encryption and security, authentication, authorization, etc., etc. So in this area, I wanted to give a few pointers to some different approaches that you may not have considered. And the first one is tokenization. And this says, and let's go back to our credit card scenario again, this says that instead of storing sensitive data such as a primary account number or a credit card number in your systems, replace that with a token that looks almost identical to the credit card number. This means you don't have to update any of your systems, but you can still store this token representing the credit card number, and when you want to actually execute a transaction, you go off to a proxy, which will return the real credit card number